everyone, this is for lab 8. So problem number 1 says solve y equals negative 2 times t times y with the initial condition of y at t equals 1 equals negative 1 over the range of negative 1 and 3. We're going to do it in 10 steps. So the first one, we're going to use Euler's. So when we do this, we're going to do the OD function, which is f. So f at ty equals negative 2 times t times y. And what that equals is right here. This equation right here, negative 2 times t times y. And then we need to initialize it. So we have our step size h equals 0.1, and we have t equals negative 1 h3, n is going to equal our length of t, and y, we're going to initialize it and do zeros 1n. Then we need to find our initial condition, which is going to be, and then our initial condition, which is y1 equals negative 1. Then we have Euler's. So for I equals 1 to n minus 1, we're going to have yi plus 1 equals yi plus h times f. So this f is technically going to be our slope, which is up here. And then we say f ti yi. And then we're going to plot it, and we get this right here. Our next one is going to be Hewin's method. So to do this, we're going to do the OD function. So f at ty, negative 2 times t times y, which is what we did up here. Same thing. And then we need to initialize. So h in this circumstance is going to be 0.1, comma 0.01. T is going to be the same, n is going to be the same, y is going to be the same, where we're just initializing it. Our initial condition is also the same, where y1 equals negative 1. And then we get into a little bit different here. So for Hewin's, we're going to say I equals 1 to negative 1. Oh, I forgot to mention there's also a for loop up here. So when we start initializing, we're going to have a for loop. And then we're going to have another for loop down here. And we're going to say S1, so slope 1 is going to be FTIYI. And that's what we multiplied up here. It's the same thing. And then for S2, so we're going to do a slope 2, which equals FTI plus H, comma YI plus H times S1. And then we're going to do S, so S1 plus S2 divided by 2. So we're just finding the average of the two slopes. And now we need to still do our Y, which is going to be similar to the one statement above, but our slope instead of this equation is going to be S. So it's going to be yi plus 1 equals yi plus h times s, and then we're going to plot it, and we get this. So this has a smaller error than the other one we solved, so that is good. And then now we're going to do a midpoint rule. So we're going to do the OD function again, which is the same as we did, and we're going to do initialize, same thing as before. We have a for loop right here, for loop right here. We initialize it all just as the same as we did before, so that is all good. And then we're going to say I equals, so for I equals 1 to n minus 1, we're going to do S1. This is where it gets different. So it's going to be the FTI, comma YI, which is similar to what we saw up here and to what we saw up here. It's all the same. And then we're going to do another S, and we're going to do the same thing as what we did up here, just a little different. So instead, we're going to do FTI plus H divided by 2, comma, YI plus H times S1 divided by 2. And then we're going to find YI plus 1 equals YI plus H times S. But we're still doing multiplying by that S because it's always going to be the same. We have to multiply our step size by our slope. And then we're going to turn that, put that on and get it, end it, do our plot, and that is what we get. So that looks good. And this is even going to be less error than the next, so that's good. And then on our M8 IV2, in this one it says on problem 1, how small should the step size h be to keep the numerical amplification below 1% over 6 full oscillations? So to do this, we're going to find our OD function, similar to what we did before, but we don't really have an equation, so we're going to do S2 negative S1. And then we need to find our time span. So we're going to do t span equals 0, comma 6 times 2 times pi. And we need to find our initial condition, same thing as we did before. And then So we're going to do 1 and 0, and then our time step, and we're doing the same thing as we did before, we're just doing the initializing. So H is going to be our step size, but we don't know what that is. That's what we're trying to find, right? So to do this, we're going to do t-span 2 minus t-span 1 divided by 15,000. And then we need an initialized time and state, which is the exact same stuff as we did before. So our t is going to be, instead of having our range like we did last time, we're going to do t-span 1, h, and t-span 2. And it's going to be the same, length t, and then s is going to be 0s to n. And then that's going to be 2 because of this over here. So that looks good. And then our s, 1, comma 1 equals s0. So we're just initializing it. So that all looks good. Now we're going to do Lewis method. This is the same thing as we did before. Now we're going to say for I equals 1 to n minus 1, s colon, comma, I plus 1 equals s colon, I plus h times the ODE up here. That's going to be our slope. So FTI, comma, SI, comma, S colon, comma, I. Okay, now we need to plot the x equals S1 versus t. So we're going to do that. We're going to plot t and then SI1 colon. We're going to do it time with position. And then we need to find our numerical amplification. So over here it says, what's it be, below 1%. So to this, we're going to find NA equals S1 S parentheses 1 and minus S parentheses 1 1 divided by S parentheses 1 1. When I get that, N equals 0.0485. That's good. That's less than 1%. So perfect. And then by trial and error, we need about 15,000 iterations for the step size. So that's going to be H, and H equals 0.0025. And that's the end.